of the CO2
Hello,
European emission
greetings
are
from
due to the buildings.
beautiful
So in this
rainy
context,
Riga,
it's important
Latvia,
to create a
presented by
trade-off between
Technical
opposite needs.
University
On the one hand, we want energy saving,
and we'll
but
talk
on the other
about
hand, we want the thermal
electronic
comfort for the
commerce and
occupant. So one of the way to do this is
decentralized payment
to
system.
adopt an appropriate temperature control strategies in heating, ventilation, air condition systems. And we know that several approaches have been
Okay,
proposed in order to realize this control. For example, we have
so
on-off bid,
here
fuzzy
is
strategies,
screenshot
neural
from
network,
Latvia online store
numerical models.
where
But
we
for
can
example,
see
the
the
former
types of
are
payments
characterized by long
for
delays in
customer of
responding.
some service
The
and
neural network algorithms
so
represent
most
another
commonly
alternative
we
approach
can pay
for a
for
problem
something
that is
online
complex,
using payment
dynamic, and
cards,
is a
electronic wallets,
non-linear system, for
and
example, the building
here in
system.
Europe also
And the
mobile
numerical
banking.
models
And we can see here all
characterized by high
list of banks and
computational
open
burden.
banking.
So in
Uh,
our works, we
Payment
want to
cards are the most
suggest
common way
to
to pay,
a simple
but
model for
it's
regulating the
complex
indoor
process
winter
of
temperature for a residential
and
house
merchant
placed in Salerno in the
get
south of
his
Italy. And this is the
funds
scheme of the
maybe in
problem.
days or
We
even
have
weeks.
three
Uh,
bodies. The first
Wallets
one
are
is the
working
inner
mostly the
environment that
same,
is described as a
acting
lumped
like
body.
service providers
Also, we have
mostly.
the external
Open
surroundings
banking is more
and
attractive
a multi-layer 1D
because
wall
it
that is described
provides
as a body with distributed parameters
uh,
which coupled the indoor and the
direct
outdoor
payments.
ambient. Also,
It's
the
done
heating system. In this
through
case, the
payment initiation service
heat
provider,
exchange
which
heat
utilizes
with the indoor
API,
environment
and the
through a
customer can
manifold-based distribution system
authenticate
where
himself
the heating
through his
emitters are fan
bank
coils.
and
Well,
sign
the wall is
pre-filled
made of different
form
layers,
of
so we
payment
have different
directly
resistance,
to
different
merchant.
capacity, and
That looks
we
nice, and
consider
it
the
will
boundary
be
condition of the third
completed
kind
in
on
a
both
working
the
day
exposed
or
surface.
even in seconds if
The indoor
two
ambient is
banks are
defined like
outside
a lumped
using
thermal system,
our
and
European
the indoor
instant
is
payment
subject
systems
to three
like
loads:
TIP
ventilation
and
load, heating
let's
load by fan coils,
go
and also the diffusive heat turbs
merchant
due to
can
transmission
do it
across the wall.
directly by
The heating
making
system
integrations
is an
with
hydronic heating system. The heat
working
source is
directly
a monoblock
using service
air-to-water
provider.
electric heat pump,
There are some
and the
benefits and
heat
drawbacks, of
emitters are fan
course.
coils. But we
Maybe the
consider
main
just one fan
benefit
coil,
here that merchant
equivalent in terms
gets
of
relocated if
delivered
fix
heating power.
problems to provider,
Fan
but
coils
pays
unit
fixed costs.
require the design load at
Okay,
the average fan speed,
but in Europe,
and the
okay, but
onboard
what
fan coils
globally?
electronics is able to
We cannot
change
use open
the
banking
fan coil
there,
speed
but globally,
according to the inner temperature
and if you
of
want to
air.
pay
And so we consider
the
three
merchant
velocity.
directly,
The
that will be also
control
easy
is able to change
because
the temperature, the outlet
if you're
water
paying, for
temperature
example,
of
from Europe to
fan coil
US or
unit of a
maybe
heat
other
pump
region, then it
according
will
to the
not be the
external
direct, but
temperature,
road of
or is able
banks
to
to
keeping
proceed.
it fixed.
It takes long time,
Well,
and of course,
this model was
pretty costly.
applied to a concrete case study, and in
Swift
this slide
API
we
project
have the
that
static and
could
dynamic wall properties.
improve this
The building
flow, but
exhibit the typical
can be
features
improved
of an
much
Italian
because of
house
its
from past
nature, because of
century. So it's
this routing.
in a massive type
It's
in
just
yellow
helping and
Napolitan tuff. Here
maybe
we have
for
the indoor and
transparency
the
of
outdoor
process, maybe some
design
reduced fees, but
temperature, the heat
it could not
coefficient
be
inner and
made in
outer, and also the
seconds
features of the
or
indoor
even inside
environment,
one day.
volume, frontal
Uh,
areas, airflow. In this way, in this
so,
slide, we have the full load heating power
if we
and
want
COP
to make
performances
our
of the
own
electric heat pump.
global system
So, the
to
goals
make
of our
payments
work
in
is an
maybe
optimization of a climatic curve in
not
the
real
city of
time, but
Salerno. So the baseline
faster.
was considered the
There is
climatic
technology,
data in the winter
different
season
ledger technology, which can be used here.
2020-21, and the
And you
baseline
know some
temperature control strategies
names of these
defines the
projects.
water supply's temperature
There are
as a linear
public and
function of the external one,
private types.
but
Of
invoking both
course,
inertia, ambient
much
inertia,
more
and by
attractive for
considering that
banking system,
most
but
severe operating
there are some
condition
problems
occurs for few
for
hours,
emissions
we can change the
because,
shape
for
of this
example,
climatic
we
curve
cannot
with
be
a parabolic one.
participant of the
And
system
we
like
can take
customer
lower the water
for
outlet
now. Maybe
temperature
it
of
will
electric
change,
heat
but
pump.
for now it is so.
Well, the shape of parabola was determined by imposition that it passes through 3 points. The first one is chosen in corresponding on T off when the plant is off. The second one was chosen in order to satisfy the stationary condition at the most common external temperature. And finally, the month with the lowest temperature ever was chosen, in this case it's February, by verifying that the resultant room temperature was at least 19.5. So in this case, the parabolic climatic regulation is all as temperature than that were lower than linear climatic regulation, but this regulation is able to guarantee minimal condition of well-being. So in this way, the code returns the temperature of indoor environment, the temperature profile in the wall, and so we can calculate the ventilation load, the transmission load. We can calculate, so at full load, the power of electric heat pump. But we can calculate also the COP, the coefficient of performance of this machine, this electric heat pump, suggested by a correction by the rule UNI N 14/825. We can calculate the capacity ratio, that is a factor of the machine, and so we can calculate the correct COP, that is function of inner temperature, outer temperature, and this factor. So, in this way, we can calculate the instantaneous electric load, and also by integrating average monthly values of heating demand and electricity consumption. So in this way, the seasonal COP turn out to be 3.75 and 40 for linear climatic regulation and parabolic climatic regulation respectively. So we have a reduction of consumption about 90%, 9%. Comfort is not affected. In fact, in the figure 6, we have the indoor temperature in February, and in this way, the maximum difference between the average monthly temperature and the target value is equal for the linear and parabolic climatic regulation. Parabolic curves allows in all cases to reach temperature above the lower comfort threshold, that is 19.5. Linear curve is responsible for values that often exceeded the target value, which necessarily involves shutting down the system. So we suggest a simple but meaningful description of the dynamic thermal behavior of a residential home in Salerno. The model is based on a numerical FEM solution, but we have a coupling the building wall that is regarded like a distributed body with the indoor ambient regarded as a lumped body. The role of a suitable control of thermal system was enlightened with reference to weather and architecture typical of the south of Italy. The inertia of the wall has been shown to adequately support the plant in the fight against thermal load in the colder weather, provided that a suitable thermal control strategy is supplied. The results clearly prove the efficacy of the proposed regulation strategy to reduce the energy consumption. Further improvements encompass the inertia of the thermal plant to describe other types of emitting. Thank you for your attention.
Thank you, and unlock equivalent in the source system, like that, to be consistent. Open problems here. Finality problem. In every distributed ledger, we have finality issue. In traditional finances, we have central point, which is a point of trust. If maybe central bank, maybe something else, if transaction is registered by central bank, then it trusts that this transaction is really finished. In distributed ledger, we have no such trust. So, for example, in the proof of work scheme, when we just randomly select next block creator by his proof of searching mathematical solution of some function, then it could be situation when there are more than one block in period of time. So if our transaction is included in some block, then no guarantee that in next block it will be still there, because there is concurrency and this transaction could be rejected by another block. So we must wait for some next blocks to make probability of our finality higher. Alternative way here is so-called proof of stake. It differs, of course, in different projects, but to be short, maybe uh, in this kind of consensus, we can assume that next block, or maybe in some blocks which are on special checkpoints, is really strong final. And that's a great benefit of this kind of work. Um, Next problem here is a refund. If you are talking about commerce, I mean, it's refunds. And basically, because we have finality issues, then we can have refund issues as well. Because when we are doing reversal transaction inside one distributed ledger, then it could be state when our original transaction was rejected and waiting for a next block, and we are creating reversal transaction for this. That will not be consistent. And if we are talking about breached systems, then the situation will be much worse, because as I said, we don't have much information about external world. So it can be fixed by using, for example, some storage of transactions to register all transactions and make a refund only if we have this transaction inside. It can be done inside main blockchain, but it can be costly because every byte inside blockchain is valued. So maybe another storages. And of course, as relayer is the main agent here, so we have problem with security of this relayer. And there are possible solution of course, we must use proofs of transactions, using signs, using link to block. That's all because relayer can make own transaction and to replace your own. So, of course, there can be smart contracts, backdoors to use, and we must have some monitoring, alerting, maybe some participants who will monitor this process and give and get some bonuses for that. And for conclusions, the main problem here is, as I said, cross-border payments. And I think that distributed ledger can be a good point here to use, to research. Private projects are not yet ready for us. We'll wait. For example, digital euro project, maybe. Um, as there are no one single standard distributed ledger, there are plenty of, we must do something to connect them. And software breach can be a solution. And of course, we must think about risks of relayers and to use proofs, check contracts, and do some monitoring. That's it for today.